iLabX, the Internet Masterclass Part 2. Welcome back to Part 2 of the iLabX. And last week we already mastered the mount signals and cables, and today we will tackle the mount Internet Protocol. Let's first start doing a short recap on what we did last week. Some important things that you should still remember. Just think about them for a second if you still know what it is, and if not, just look back so that you know again what it was, because today we'll work on layer 3, and as you remember from the layer model, it's on top of layer 2, so it requires layer 2 to function, and there's also lots of interaction between the two layers, and therefore it's important that you still remember the most important concepts. Okay, so what did we look at? So first thing we looked at is data versus signals. So this was, how can we, let me just get the cable. So this was, how can we get data that we have on one side into a signal that we can transport over the cable here, that is received on this side, that is decoded again into this. So the signal is received and it's decoded again then into data. So this was data and signals. Then the next thing is the shared physical medium. So there, last week I showed you the antenna here. So there we have a shared medium, which is the air. And with this thing here, so with a cable, with a copper cable, there you could use these things that work like the multiplex, the switches, and everything that is connected to the switch is potentially in the same collision domain, but it was not, as we've seen, because the switch is exactly resolving this, but with the hub it was like that, it was like a multiplug. Okay, what else did we look at? So we looked at noise, so there you remember the vacuum cleaning thing here, so that I could not talk to you while Jonas was doing vacuum cleaning here. Then the next thing is timing, so when you send a signal over the cable, that it's important when the signal goes up and down, so that you can then decode the symbols afterwards. Then we looked at addressing, so how can these hosts on the shared medium address each other. We looked at topologies, so how are the things connected, and our clouds come to wonderful bright blue sky here. We looked at unicast and broadcast on layer 2 already, so we'll have a look at these mechanisms on layer 3 today. And we looked at payloads, we looked at trailers, and probably most important, we looked at headers, and these 3 cloud pieces here. So this is something that you will see on each of these mountains here. So also today. Okay, cool. Having recapped this knowledge, you're perfectly ready to start the interesting journey on Mount Internet Protocol. And today we'll walk this path here to the highest point again. And I already wish you a lot of fun with that. So what are the details of today's route? Well, we look at layer 3, the Internet Protocol, and the key thing we look at is, last week we looked at things that are directly connected, compute nodes that are directly connected, how can they talk to each other? And when you think about the internet, of course you're not directly connected to all the web servers that you want to talk to, and therefore a typical internet connection goes over multiple hops. So typically you have something between 3 and 20 hops through the entire internet. So if you want to talk from Germany to Australia, for instance, then you will have several hops. And last week we looked at the addressing on this segment here. And so we used the MAC addresses for that. And today we will introduce other addresses, namely IPv4 and IPv6 addresses. And these addresses are on top of the MAC addresses, so the MAC addresses are still used because on the segments you need them to forward between the directly connected hosts. But on top of that we have the IP addresses, and they give the information where a packet should finally be put to, and so this putting is called forwarding. And on each of these intersections here, you typically don't have only one connection but multiple, and on each of these intersections you have to decide where to send it to, and this exchange of information where a packet has to be sent, so if it should be sent to Australia, if it should be sent to America, if it should be sent to Africa, or if it should be sent to Europe, for instance. So this process of exchanging this information is called routing. But more about that just today. We'll also look at IPv6, which is a newer mechanism for doing this routing, and we look there especially at addressing. So this is where the IP addresses are used. We'll see that v4 and v6 addresses are similar the way they are built, but they're different in size and and also in the notation. We'll look at subnetting. So this is similar to how can you make sure that you first send the packet into a certain area and then there you do the distribution. Like when you look at a parcel delivery, this is very similar to that. We look at auto configuration. So how can computers on layer 3, so these hosts and routers, how can they automatically get an IPv6 address? We look at supporting protocols. So the NDP protocol, for instance, that is used for doing a resolution between these layer 3, so the final destination of the packet, and the layer 2, so which is the next hop of the packet here. It also does other things, as we'll see. ICMP, which is a protocol that helps us to get to know if there's a problem with the delivery of the packet. So for instance, if the road is too narrow here and we need to do fragmentation, what we will also look at in this lab. We look at the layer 2 and layer 3 addressing that I was talking about before. We look at the routing versus forwarding I was talking about before, and we look at this fragmentation issue that I was talking about. Like when you have a big packet and the road is too narrow, that you have to chop it into different pieces and then send it around. And we'll close today looking at static routing, and static routing is when you have a topology here of layer 3 components and you want to send a packet from one part of the network to another part, that you configure statically the routes. So if I'm here, shall I send it to Europe? Shall I send it to the US? Shall I send it to somewhere else? That you do that statically, and after today you know how packets can travel from one end of the internet to another end of the internet. But in the actual internet, this is not done statically, but it's done dynamically. And this is exactly what we will look at then in the next part. So this is what part 3 will be about. But in order to understand that, we'll do the basic mechanisms of this internet protocol today. And we also have 2 parts for the internet protocol, because the internet protocol is what's holding the internet together. Okay, so I'm very excited to go through the different parts with you. My team is also excited. And so we hope that you will also enjoy it, and I wish you a lot of fun going through the VLAB Layer 3 Internet Protocol with the following nice topics on our journey. Enjoy!